Let's try to derive the binomial option pricing model. The essence of deriving this is in the arbitrage. Now, what do you mean arbitrage? You make risk neutral profits. And what is a risk neutral profit? It is earning RF, that is the risk free rate, without having any such risk. And let's see how do we do that. So, say you have a stock S0. It has a probability P1 attached to it, that it can go up to the value of US, or alternatively it has a probability of 1 minus P, that it could go down to DS. Let's give some names to these. Let's say S0 is 100, and upside it could become 120. uh, let's just say this becomes 125, and this becomes 80, because there is an underlying principle that u should be u d should be equal to 1 by u. That's a principle that is used sometimes. Okay, so in our case, u would be u is equals to 125 divided by 100, that's 1.25, and there you derive d, that is 1 by 1.25, that gives you 0.8, and here you get d is equals to 80 divided by 100, that is 0.8. Okay, now what do we do about it? So let's just say you create a portfolio V. The V portfolio has certain number of stocks hash n at the value of stock price 0, and then you short a certain calls, that you write certain calls, so you earn a premium of these calls. Okay, in the upstate, that is VU, you will still have the calls, still have the stocks, but in the value of the stocks would move upwards to US, and you would also have a payoff CU, that is it could mean that you need to pay for this call. Okay, and then you have VD, that is value at the downstroke, that is you will still have the stocks, you will have them at a DS value, but you will have a call value of CD. Okay, the essence of this is these two, that is VU should equals to VD. Why? Because we are risk neutral, as it is risk neutral. Okay, so we need to first understand what how do you get to risk neutral. Okay, so let us try to first understand CU value. CU would be maximum of 0, because you can lapse your option, and your stock value as on date minus the exercise price. So let us determine our exercise price as 100. Very simple. Okay, in CU you have upside, so maximum of 0 comma the upside is 125 minus 100, that gives us 25 as the answer. All right, and this is your value of CU, that is your upside payoff. And similarly CD would be again similar, maximum of 0 comma DS minus E is equals to 0, because DS minus E would be 80 minus 100, that's negative 20. Negative 20 is lower than 0, so you get 0, that is CD. Okay, now the essence again, we come back to hash n times S0, that is 100, minus CU, which is if I'm not wrong 25, is equals to hash n times 100 minus 0, because you have value of the upside equals to value of the downside. Okay, and that is where you solve for your hash n. Okay, I mistakenly put this as this should be 80, this should be your 125, and you can see hash n is simplified basically into CU minus CD divided by your US minus DS. That is, in our case, CU is 25, this is 0, and our stocks move 125 minus 80. So 25 by 45, and that would be something like 5 by 9. So for every 5 stocks you hold, so how do you interpret this? This is the hedge ratio. Hedge ratio. Okay. So 5 by 9 would mean 5 stocks short 9 calls. Okay. So let us try for once. So you buy 5 stocks. In the upside it's 125 minus CU which is just 25, and times 9, and again you 5 times 80, that is the downside, minus 0 times 9. Okay, so this is becomes 0, this becomes 45, this becomes 400, this becomes 525 if I'm not wrong. And then you have, what is it, 480. I'm mistaken, I guess. No, this doesn't become 45. That's completely wrong. It becomes 225. Okay, 225 again. Am I wrong? This becomes 625. Okay, now 400 is equals to 400. Hence, it's true. The relationship is true. All right. So let's say now we have VD equals VU. It implies that at hash n holdings we get risk-free portfolio, and if a portfolio is risk-free it should earn risk-free interest. So RF plus 1 times value at 0 should equals to VD should equals to VU. Is that right? All right. That must be true. So value at 0, let's just say we have, so here's when we define our RF. RF, let's say, is 1.1. All right. That's not 1.1, that's just 10%. Okay. So 1 plus 10% times V0 is equals to, we can take the value upside, let's just say. So you move this down here and you get value at 0 is equals to the value at upside. What was the value at upside? It was 400. Okay, this was VU and this was VD, both of them being the same. Okay, so 400 divided by 1.1. Now if you remember, the the V0 value is just hash n times S0 minus the number of calls. And if I remember correctly, we determined that we need to buy 5 stocks at the price of 100, and we will short 9 calls at just C. Okay, so here we can get the value of C as follows: 400. Okay, let's just say if you move things around, everything should be divided by 9 in the first place, and this moves that side, that moves this side. So 500 minus 400 divided by 1.1. Let's take out our calculator. That is 500 minus 400 divided by 1.1. All of it divided by 9. That's 15.1515. So you get 15.15 as our call value. Now this is the call value. So we can also derive call value as follows: CU times P plus CD times 1 minus P divided by what is called 1 plus RF. Should also give you the same call value. And here we solve for P to get the probability of this happening. Okay. And how do you get that? You get it by the 15.15 times 1 plus RF is equals to, since CU is 25, we just attach a probability to it, and since CD is 0, so you do not need to do any hard lifting over here. And if we divide everything by 25, we should be fine. So divide by 25, divide by 25, since this is just 0, so you get what is, again we have this times 1.1 divided by 25, that's a 0.67. that is 2/3 probability of it moving upwards. And this could also be determined as follows: 1 plus RF minus the probability, the value moving downwards, and U minus D, if I'm not wrong. If you put the right values over here, 1.1 minus 0.8, 1.25 minus 0.8, this is 0.3 over 0.45, 0.45, that's again 2/3. So you can also get these values from this formula, but I prefer the bottom up approach, that is just getting things done from the bottom up. So this is just a video deriving the whole idea of binomial. And what I like to think is in terms of a portfolio. So you can always have the call value defined as the number of stocks you buy times the value of the stock currently minus the debt you have taken. So the number of stocks, that is hash n, is also the delta, that is the change in the payoff divided by the change in the stock value, determined as the Cu minus Cd divided by S0 times U minus D. Okay, and the number of the debt you want to take is D times Cu minus Cu times D. No, I just wrote it completely wrong. U times CD. Okay, divided by again 1 plus RF times U minus D. Okay, and that's where you get the famous delta position, which is just your delta times S0, and if I'm not wrong, you get the boring part, but this is where you get the call option value again, that is the hash n times S0 minus the borrowings. This is from the replicating portfolio part. This is derived from above again. This is just the same formula, but the debt value is just derived again from the replicating portfolio. This could also be done in various manners. You can do Cu times 1 plus RF minus D U minus D plus CD. If I'm not wrong, this should be U minus RF plus 1, okay, divided by U minus D, the whole divided by 1 plus RF would again give you your call value. These are few formulas you need to use here and there. This is just from the bottom up approach again. That's just a video that I wanted to make so that I don't forget how to derive these things from bottom up. And this is me signing off.